inviting me. Second, I must start with apologizing because I'm not a broadcast engineer. I'm a telecom guy who became an internet guy and have been building streaming platform for the last 10 plus years. So it's very likely I'm gonna say some stuff that sounds just stupid. If you start asking me very tricky broadcast questions, I will most likely not be able to answer them. So I apologize for that. You might not have heard about Agile Content or Edge, where I actually come from the beginning. We've been doing distribution solutions for TV over IP for many, many years and building OTT platforms, some 17 years now. And we are about 300 specialists in distribution across the globe. And a while back, maybe 1.5 years ago, we started to think about what we were doing, and we realized that doing TV is kind of two different worlds. We have a broadcast world, which is simplex, content-centric, and if you excuse me, pretty slow-moving compared to internet. The internet is all about full duplex. It's very user-centric, and it's relatively fast-moving. I think it's the fastest-moving technology platform that we've ever had, right? The question is, what does that mean for TV? And we think that one of the challenges was that the question engineers like ourselves should ask ourselves is not necessarily how internet and IP can be used to distribute TV. It's more how can TV be transformed using IP and the internet, and what does that mean for how TV is produced. Luckily, we have been working for about a year with a well-established broadcaster who have since a while adopted an internet first strategy where they think that the streaming is actually the most important, and the traditional broadcaster or satellite or terrestrial is kind of secondary. And together with these guys, we identified a number of things we wanted to address. One thing being that how can we make the TV service a kind of user-centric, meaning that first of all, we can cope with the fact that different users might have different preferences on how they think, what they think quality is. Some thinks quality is great pictures, others think that quality is low latency. And ultimately, that should be something that you can adapt to the user instead of deciding that in the production, right? Another thing is it possible to do more personalized curation? Does each user need to get the same TV or the same stream? Or can we actually curate the stream individually for the user, if not individually, at least quite granular fashion? And also, can we build a system that is kind of caters for a future where we have more engagement and interaction between the end user and the content? That's one thing. Another thing, we want to be able to mix sources, because today there are tons of cameras out there. We have broadcast cameras, obviously, but you also have all the cameras in the mobile phones and other cameras that are connected to the network. And wouldn't it be great if all these cameras could be used in the production? But still, all these cameras in sync. I think sync is something I've noticed a couple of times throughout this workshop. So I think that's something I will get back to. And then also solution where you can actually mix in content from social platforms directly into the broadcast production. And last, and definitely not least, find ways that are more flexible in how you operate and how you work, both from a kind of infrastructure perspective, that the infrastructure, the cost you have for the infrastructure follows the value you create rather than the peak capacity you have. And then also the use of a combination of private public clouds so that they can complement each other, and a structure in the platform so you can organize organization in such way that different parts of the organization are responsible for different pieces, but they don't necessarily always have to plan if they're doing something with the neighbors, if you will. So that if you're working with the graphical systems, you can do upgrades and so on the graphical systems without necessarily taking the current graphical system down and talking to everyone that is working with that. And also, we wanted to build a solution, especially now, I mean, during the pandemic, a solution where you can do the actual production not only remotely but also distributed. So you can more or less sit in your living room and produce TV show instead of going into the broadcast. And we try to address all of this, and we have been getting quite a bit in this ambition. And we started with introduce a concept of two different kind of productions. One thing we call primary production, and another thing we call secondary production. And the primary production is what most of us think about. This is when you hook up the cameras.
Johan, we're losing your audio a bit occasionally. I don't know if your mic's
right.
That's a bit better.
I'll try to sit closer to the microphone. So the primary production is the piece where you typically do the traditional production. This is where you hook up the cameras, and it could be SDI cameras, NDI cameras, WebRTC sources, or other. I will come to in a minute what EFP is. And what you do here is that you produce the original feed. All production here is frame accurate, and this production is also aware of a secondary production layer. I will come to what that means. And the price you pay for this, being frame accurate and operating in a relatively high bit rate, is cost for bandwidth and cost for CPU. But the output is the so-called program out. And then we have the secondary production. And the secondary production works in the segmented domain, if you are familiar with streaming. So when you do this production, you're actually, instead of working with frames, you're working with chunks, and you stitch chunks together to more personalized versions. Advantage with this is that you can do more or less down to individually curated TV channels at very low cost, because you don't need to re-encode anything. The downside here is that you need to stick to the segment boundaries. So you don't have the same time resolution as you have in the primary production. But if the primary production done a good job inserting metadata, you can do secondary production that looks pretty good as well. Today we're going to talk about the primary production because that's what we've been working with together with this broadcaster. We built a solution that looks like this. So we created two pipelines, and the reason we created two pipelines is to support the idea of having distributed production. So we create one pipeline that is a very fast, low quality production pipeline that is roughly 1 megabit per second. So the encoder that sits on site, typically either inside the camera or it's a PC that you hook the camera into, produces two streams. It's the 1 megabit per second stream, and then we have a slower but with higher quality stream, typically 50 to 100 megabit per second. Also compressed though version. Both these versions are sent up to the cloud. And it's the one that has the lower quality but also the lower latency that is used for the production. So in the multi-viewers, that's the feed you're gonna see. So everyone operating in creating the TV channel works in that one. And that stream typically have a small time advantage, right, to the delayed one. And that time advantage today when we do these productions is 3 seconds, but it's configurable. It could be 1 second, it could be 5 seconds, but 3 seconds is a good balance between latency and quality we have figured. As far as possible, we send all feeds up to the cloud. And the reason for that is because we want to have all content available and not waste any content. So all cameras that are producing content are delivering this content up to the cloud, even though only a few of them are actually used in the live production. But for maybe on-demand assets used later, you have the other cameras that you can. And all of this applications, since they run at the cloud, you only need a connection of roughly 3 to 5 megabit per second to operate this. So you can basically be in your living room over Wi-Fi and do the mixing from the living room with an iPad. In order for this to work, a few times a day I've heard the word sync, and I've heard the word signaling time and so on. So we had to, if you will, internet style, build a new protocol. So we built a protocol we call Elastic Frame. It's an open source protocol, so you have the links in the lower part of this slide where you can go to if you would like to read more about it or even try it. So this Elastic Frame protocol have a number of advantages. First of all, we have better timestamps than you have in transport streams, and so we have 64-bit tie. This is atomic time. Elastic Frame have significantly lower overhead than transport streams have, and we also optimize the MTU to the underlying IP link, so we get better link efficiency using this compared to other formats. We also have duplex built in here. So since we can transport different kind of media formats and different subtitles and audio formats as well, with this duplex solution, the kind of sender and receiver can negotiate what formats to use for a particular production. We also support out of order and head of line problems, meaning that we get a much more efficient utilization of the network with this. The transport is agnostic and multipath, so we can use protocols like RIST, SRT, and SIGSI as underlying transport protocols, and then we can bond them. We can also use different kind of access networks in parallel, so we can use Wi-Fi and 5G in parallel and then bond the media on the receiver side. And thanks to this, we also have very good redundancy built in the protocol. So that's what we did. I think if you're interested more about this, you should visit this GitHub link, and you can also try it because it's open source. If you look into more the applications we built, so we built on this. If you're doing a production and you have an SDI camera, on to the far left here you see something called capture, and that's typically a standard COTS PC that you slot in a Blackmagic card in, and you should also, depending how many sources you have, slot in a GPU card. So if you build a COTS server for roughly £2,000, you will be able to provide to deliver or to manage 6 concurrent SDI HD streams on that machine. And in this machine, then we do encoding, and then we transport this media using SRT, RIST, or SIGSI, or UDP to these two different cloud application stacks. One application stack is the one that you're using for the production. That's the yellow one. So that's the one that have all the user interfaces and the tools. And then there's another one that operates on the higher quality version, but with a slightly higher latency then, that puts together the actual program out. And again, the advantage is, since you have a heads up of about 3 seconds, if something happens, you actually, the ones working with the production are, if you will, in the future from a viewer perspective. So what you're working with is ahead of time. And some of the cool things here then is that next to running this on COTS machines and use SDI cameras, you can run this on a mobile phone, and you can synchronize the mobile phone with the SDI camera. So this protocol includes support for synchronizing a variety of different cameras. And we also have support for if you have cameras with different lags in the camera, you can offset them. So if you have it's obviously the slowest camera that sets the standard for the production, right? And you can offset the time in all other cameras to match the slowest camera. What we're doing now? A few things. So we are planning to start doing trials on 5G and 5G in combination with Wi-Fi. And this is to do both to get as much spectrum available as possible, but then it's also to be able to do redundancy and so on in multipathing. We're going to build a EFP library for mobile phones, so anyone who wants to use this in their app can download it, and when they build the app and introduce this in the app. Might also use WebRTC, but the problem with WebRTC is that we can't synchronize WebRTC sources with SDI sources due to limitations in the WebRTC interface, in the protocol. And then we're working with a lot of other stuff, including the backend to manage all of these sources. One of the cool things with this is that you can more or less send an email or an SMS with an invite URL. And then if the user gets that, clicks on that invite URL, you add that camera to the production simply by tapping the URL. And also sync that camera up together with the sync of the production. And we're also working on some other stuff like a much better mixer. The mixer we have today is very simple. And as a matter of fact, we don't plan to do our own. We have an API where you can plug in your favorite mixer if you don't want to use ours, but you can also use this. And I think we've heard also in the previous presentation to talk about metadata. We are increasingly creating metadata of all sources and also what you're doing in the mixer. So every time you choose which camera you want to use and so on, we create metadata that is stored together with that so that can be used later when doing production afterwards, when doing alternative productions in parallel.